Okay, so today our goal will be to look at the relationship between the volume of a cylinder and a cone that has the same base area and height. We'll also do the same thing for a rectangular prism and a pyramid that has the same base and height. Okay, and then we'll take a look at the sphere. Okay, so I know that some of you guys that have maybe seen this applet already. We talked about it a little bit yesterday with a Google Meet with a few of you guys. So what I want you to first recognize with this is I want you to look at this sphere, or sorry, this cone, and compare it to this cylinder. So I want you to tell me a couple things that you notice about those two. Okay, so did you notice that they both have the same height and that their bases are the same? So the circle is the same size. Okay, so in the Edpuzzle, I'm going to give you a link to this applet, and you're going to play around with it a little bit. What I want you to do is look at what the relationship is between the volume of the cone and the cylinder. Okay, so what you can do is take any of the objects, put them in the fill. Okay, you're going to fill it with water, and then you can take the object and once you put it on top of any of the different shapes, it will like empty it into the other one. Okay. Okay, so I want you to compare these two shapes. So go ahead and fill up the cone and see what you think the relationship is between the cone and the cylinder. Okay, so how many cones did it take to make a full cylinder? Did you fill it up one time? Pump it out. Second time, pump it out. And then a third time. Okay, so here's what you should have seen, that the relationship between a cylinder and a cone that have the same base area, so these bases must be the same, okay, and the same height, is that if you find the volume of this volume should be 1/3, okay, or if you find the volume of this one would be 3 times the amount, okay. So like, let's say that the volume of this cylinder ended up being 30. What do you think the volume of that cone would have to be? Okay, so hopefully you thought 10. Okay, so we'll go ahead and just empty that out. Okay, so then I want you to take a look at the pyramid, okay, so versus the prism, okay, and what do you notice about the relationship between this pyramid, this rectangular pyramid, and this rectangular prism? Okay, so did you notice that they had the same height? Okay, and that their bases were the same. If I put the bases on the bottom, they're the same size. Okay, so same thing as with the cone and the cylinder. I want you to see if you can find out the relationship in volume between the pyramid and the prism. Okay, so I'll give you a chance to open the applet and play around with that. Okay, so when you second fill, so one time was not enough. 2 times wasn't enough. Okay, so it looks like we needed to fill it 3 times, okay? So similarly to the cylinder and the cone, okay, if I have a pyramid with the same base, okay, as my prism, okay, and the same height, okay, so the heights must also be the same. So these base areas must be the same, okay, and their heights must be the same. If I find the volume of this one is 1/3, okay. If we were in class, we would have also played around with a triangular prism and a triangular pyramid that had the same base, okay, and height, and we'd notice that it was still 1/3, okay. As long as the base areas are the same and the heights were the same, the relationship between the volume of the two has ended up being 1/3. Isn't that kind of cool? Okay. So that kind of leads us to possibly a formula then. Okay. So if I have my cylinder, we should have figured out the other day, to find its volume, you're going to do radius times pi times the height. Okay. So then how would I find the volume of a cone? The volume is just going to be 1/3 times the radius times pi times the height. Okay. You could also do radius times pi times the height and then divide by 3. All right, so I know we found lots of volumes for these. To find the volume of this prism, we're going to take length times width times height. Okay, so length times width gives us area to the bottom. Height is the number of layers. To find the volume of the pyramid, we're going to do 1/3 times length times width times height. Okay, so then basically that will work for any prism versus the pyramid. To find the volume, you're just going to do, if it's a prism, okay, you're going to do whatever the base area is times the height, okay? And for a pyramid with the same base area and height, the volume would just be 1/3 the base area times the height. Okay, so those are the relationships you should have seen. Okay, so I want you to try and figure out one more. Okay, so I now want you to go back to the applet and see if you can figure out, well, take a look at this sphere. Okay, so sphere is like a ball like object. I want you to look at, we're going to focus on kind of the sphere relative to this cylinder. What are some things that you notice about that sphere versus that cylinder? Okay, did you think, okay, it looks like they have actually the same height, okay? And the circular part, okay, so the diameter of the cylinder and of the sphere is the same, okay? So I want you to go ahead and play around with the water and see if you can figure out what the relationship is between these two. So I'm going to go ahead and fill the sphere. And I'm going to empty it into the cylinder. Okay. Huh. It wasn't a half, was it? Or a third, for that matter. So it definitely has more volume than the cone. What fraction does it look like it might be? Okay, if you thought 2/3, you were actually right. Okay. Now if I try and fill another one, let's see what happens. I'll try and dump this in here. Huh, okay. So do you see how it didn't take a whole? So if you look at the relationship between these, it would take 2/3, okay, the volume of the cylinder, if I took it times 2/3, would equal the volume of the sphere, okay? or I'd need 1.5 spheres to actually fill the cylinder. Okay. So, and here's kind of interesting how to play around with. If I empty both of these. Oh, what do you think would happen if I took the cylinder and dumped it into the sphere, and then I dumped it into the cone? Isn't that kind of cool? All right, so a sphere plus the cone equals the cylinder. All right, so if I add this to our list over here, if I do a sphere, what is its relationship between these? Okay, so the volume of the sphere is 2/3. Okay, the volume of the cylinder. Okay, maybe I should have written it like this. So 2/3 the volume. Okay, so if I wanted some kind of a formula, I'm going to do 2/3 times radius times pi times height. Okay, times the height. Okay, and the height really is the same thing as in a sphere. The height has to be the same thing as the diameter of the sphere. Okay, all right, so 2/3. That's going to be my relationship. All right, so knowing that, I'm going to have you figure out a couple different things. Okay, what if I had a cylinder with a radius of 12 and a height of 24? How could I find the volume of all three of these? Okay, so for the cylinder, I'm going to do what I've been doing kind of like, for the last couple of days. I'm going to do radius times pi times height. So 12 times 12 times pi times the height. Okay, so I'm going to end up getting 1,000 or 10,851.84. Okay, so if I know this is the volume of the cylinder, how am I going to find the cone? Okay, so it should just be 1/3 of that. So I can either multiply by 1/3, that answer by 1/3, or I can divide by 3. Okay, so that means that the cone should be 3,617.28. Okay. All right, if I wanted to find the volume of the sphere, I could go back to my cylinder. Okay, and I'm going to take 2/3 of that. So times 2 divided by 3, so times 2/3. Okay, and I get 7,234.56. Okay, would be my volume. Okay, so, and then interestingly enough, my 1/3 and my 2/3 should equal my whole cylinder. So actually, if I add these two things together, I should get my 10,851.84. Okay, so the big idea here is that if you have a prism, okay, and a pyramid that have the same base and height, the volume is going to be 1/3. Okay, and if you have a cone and a cylinder, kind of similar idea. Okay, although remember that cylinders is not considered a prism and a cone is not called a pyramid, but its volume relationship would also be 1/3. And then if you throw the sphere in there, the sphere, okay, is going to end up being 2/3 the volume of the cylinder. Okay, so you're going to have a chance to do some practice problems next. I am going to give you 2 days to get the practice problems done, okay? So if you end up having a lot of trouble with them on the first go around, make sure you come in during office hours and ask for help.